Good morning, students. In the previous video session, we have discussed about the Hooke's law and the derivation of elastic energy, then the application of elasticity. And today we are going to discuss a new topic. You can see in 7.3 fluids. First thing, what is the meaning of the word fluids? Fluids. What is the meaning of the word fluids? You know, the meaning of the word fluid is what? Flow. So, it may be the flow of water, it may be the flow of gas. So, anything which is flowing things, that is what we are saying fluids. And you know, these fluids which can be seen in everywhere in the world. We also know that from our smaller grade we are studying Earth is about water. 2/3 of our Earth is surrounded by water, and only 1/3 of is land part. That is what we have learned from our childhood. So you know there are some parameters which will be used to indicate this fluid, and in that first one is the pressure of a fluid, then the density of the fluid, then relative density, or you can tell that specific gravity of fluid. What is meant by pressure of a fluid? You know, from our childhood we are studying the definition of pressure. We know that force acting per unit area, that is what we are saying pressure, force acting per unit area, that is what we can define pressure. The thing is, you know this thing, suppose assume that we are diving inside the sea. When we are diving inside the sea or swimming pool, we know that when the depth increases while we going inside, we will feel more pressure, or we can tell that something we feel some force which is acting upward. Actually, what is that? While we are going inside inside the fluid, we are feeling more pressure. So you know that fluid, in this case, pressure of a liquid means you can tell that the force which is acting on a smaller area. Force per unit area means if the area is small, there we are acting more pressure. Suppose we know we have learned in our smaller grade. Suppose you are hammering a nail on a wall. So nail means their smaller area, and we are applying the what more pressure. When the area decreased, what will happen to the pressure? Pressure will increase. In the same effect, you know that cricket players and other players, they use spike boots. They use spike boots because when they use these spike boots, it will increase the pressure, so they can escape from what slipping. That is the reason why the cricket players and other players they use the spike boot while they play. We know the relation also. Pressure we are indicating force per unit area, and the unit used, you know what is SI unit of pressure? Newton meter square, or Newton per meter square, or you can use what Pascal. So that is the first parameter, and the next parameter is density. You know, density means what? Mass per unit volume. So the density of fluid also you can define as mass per unit volume, and its unit is what? SI unit of density is what? Kilogram per meter cube. Okay. Now the relative density, that is also another parameter. It is the ratio of the density of the substance to the density of water at a 4 degree. So this relative density we can define as the ratio of the density of a substance to the density of water. So if we are taking two substance, one is water and another substance, this relative density we can find out the ratio of these both. Suppose we are taking the density of mercury. We know the density of mercury value is 13.6 into 10 to the power 3 kilogram per meter cube, and it's we know the density of the water, it is 1.0 into 10 to the power 3 kilogram per meter cube. So the density of mercury is 13.6 and the density of water is 1.0. If you are finding the relative density of that fluid, so what we will get means we can find out these two by, you see, 13.6 into 10 to the power 3, it is the density of mercury, and density of water is 1.0 into 10 to the power 3. So if we are finding these two ratio, we will get 13.6 because 10 to the power 3, 10 to the power 3 cancel, so 13.6 answer we will get. This is what we are saying, the relative density of a substance. So these are the parameters we can explain. We can use to explain about the fluid, pressure, density and the relative density. Pressure means we know force per unit area, and we know the formula P is equal to F by A, and we are using the formula Newton per meter square. And density means, you know, density means what? Mass per unit volume and unit kilogram per meter cube. Then relative density, this is the density of one material and this is the density of another material. If you are finding the both material ratio, so that will be the relative density of a substance. Next thing is pressure due to fluid. Pressure due to fluid column at rest. So pressure due to fluid column at a rest. So in this we are finding the pressure due to the fluid column at rest. It means you can see here one diagram. This is what you can see in one container. Some water is there, and inside this container we are keeping an object. We are keeping a sample, and this sample is kept at rest, and for this we are finding the pressure. You know this thing. Maybe you have the feelings of going in flight and all. Those who traveled in flight and all, you know, while the flight moves up, it goes up, we feel some pain in our ears. What is the reason? Or you know that sometimes we used to go for picnic and all in Kodaikanal, Ooty and all. While we climb the hills, we feel that there is a pain in our ear. What is the reason we are getting pain in our ear while we climb the mountain or while we fly in aeroplane? The reason behind this is the pressure. Actually, you know that when we climb some mountains or when we go a height place, the pressure is getting reducing. Outside pressure is getting reducing. So at the atmosphere pressure we can tell, or the outside pressure which is getting reducing. While this pressure reduce, what happened means inside our body the in pressure is getting increasing. So this is the reason we are getting pain in our ear. So this thing also, while we swim inside the water, when we are going inside the water, we feel that more pressure. We feel something is pushing us back because water. That is water we are saying. So we feel more pressure. That is water. That is, while we go inside, the depth is increasing. When the depth increase, pressure also increasing. That is the reason we are getting pain. And this pressure we can find out by keeping a sample inside a container. That is what you can see the diagram here. Here there is a sample kept inside a container, and this sample, suppose you are looking from upside, from here you are looking, you can see that the sample which is same as a cylinder. So when we look this sample from outside, so when we look this sample from outside of this container, we can see that it look like some cylinder. That is what here it is saying. Consider a water sample of cross-sectional area. You see, this cross-sectional area means, the water. It has same area. That is what I said. When we look this from upside, you can see this sample as a cylinder, and its cross-sectional area also we feel that it will be same. So that is what the small sample which is kept inside the water and its cross-sectional area is same. And what happened means, here you can see two height h1 and h2. What is this h1 and h2 means? H1 is the height from this point. Above this sample some liquid will be there. That part we have taken as level 1, and that is height 1 and height 2 until this end. So up to this sample height from this liquid level, that is level 2, that is what we have taken, height 2. Now we know this thing. So again remember that here one sample, so a cylindrical sample which is kept inside water, a liquid, and its cross-sectional area we can keep some A and H1 and H2. That is water depth from this air water interface. Here air, here water. In the between these two interface there is some height. From this sample, above this sample level 1 we have taken, and until this sample this taken as level 2. And now you can consider there is a force acting. This thing, when some object is placed inside the water, if it is rest also, you see it is in between the liquid. So when this sample is in between the liquid, there are some forces acting on it. What forces acting on it? So there must be some downward force and there must be some upward force. If we are taking the free body diagram, like this you can draw. Upward and downward. Downward you can take F1 and upward you can take F2, and here the force mg, gravitational force, also acting. So you see this is a sample, and when the sample is inside the liquid, there are two forces acting, upward force and downward force. Upward force is F2 and downward force we have taken F1. Also downward there is some other force which is acting, that is what mg. Now if we are applying the Newton's law on this sample, we will get what we will get? F1 plus mg equal to F2. F1 plus mg equal to F2 we will get. Now this thing, this is, you can keep it as equation 1. Now we need to find out this mass. We need to find out this mass. We know how to find out the mass. We know the density formula. Density is equal to what? Density is equal to mass per volume. From this, mass is equal to density into volume. So, mass we have found, mass is equal to density into volume. Now, the volume of this sample. Volume of the sample we can find out by using volume is equal to area into height. Here height means the height difference H2 minus H1, and area A, so equal to volume. So V is equal to A into H2 minus H1, that is what volume. Now you can take this V value in this equation. Instead of this V, you have to substitute this V is equal to A into H2 minus H1. So it becomes M is equal to rho into A into H2 minus H1. Now you can keep this as equation 2. Now what you have to do means, instead of this M value, you have to substitute this equation 2. So substitute equation 2 in equation 1. So when you substitute, what you will get? F1 plus, instead of M, what? Instead of M, you have to substitute rho into A H2 minus H1 equal to F2. Here G also there, because in this equation F1 plus mg equal to F2. Instead of mass, we have substituted this rho into A into H2 minus H1. Now we know this thing. This is what F1 means the force which is acting, the force 1, and F2 means the force 2, that is the force which is acting upward and downward. We know that formula, pressure P is equal to F by A. So from this formula you can find out F is equal to P into A. So F1 you can write P1 into A, because area will be same, and you can write F2 is equal to P2 into A. Now what you have to do means, instead of this F1 you have to substitute P1A, instead of this F2 you have to substitute P2 into A. So now you can take the equation F1 plus what? Rho into A H2 minus H1 into G equal to F2. Instead of F1 you can substitute P1A plus rho A H2 minus H1 into G. Instead of F2 you substitute P2A. Now here A. So take the A outside commonly. So when we take here A inside, P1 plus rho H2 minus H1 into G, here P2A. Reduce this A and A, cut this A and A. So remaining we will get P1 plus rho into H2 minus H1 into G equal to P2. So now we got the P2 value. Pressure to P2 equal to P1 plus rho into H2 minus H1 into G. This is a pressure due to the fluid column at a rest. If you are keeping some object inside the liquid, this much pressure will be there. Now you can take a case. Assume that this level 1. Now the level 1 is air. So there this atmospheric pressure PA is acting, and the height instead of this H2 height, H2 instead of H2 height, here we have taken this height is H2. Here instead of that H2 we have taken H, and H1 will be what? Here in the level 1 H1 is nothing, so H1 you can take 0, H2 you can take H, and pressure 1 you can take what? PA, atmospheric pressure. PA means atmospheric pressure, that is P1, and P2 is P, pressure which is acting in the liquid. So you can take this case, assume that P2 is equal to P1 equal to what? Atmospheric pressure PA. H2 is equal to H. H1 is equal to 0. Now you can substitute all these in this equation. So what you will get? P equal to PA plus rho H2 instead of H2 H minus H1 is 0 into G. So you can write this equation, P is equal to PA plus rho H minus 0 is H G. You can rearrange, write this equation, P is equal to PA plus rho GH. Now you can neglect this PA, atmospheric pressure, and we will get the pressure at fluid. P is equal to rho GH, density, gravity, height. So this is what we have proved. Pressure is depending upon the density, gravity, and what? Only the depth. So this is what parameter. You see, pressure due to fluid at a column at a rest. From that we have reached this formula, P is equal to rho GH. It means what? Pressure is affected by only density. Pressure will be affected by only due to density, gravity, or the depth of the liquid. So the depth of the liquid can affect pressure, gravity can affect the pressure in a liquid, density also can affect the what? Pressure acting on the liquid. So this is one important question in this unit. Again you can go through this. So you see one container. Inside this container one sample is kept. That sample is a cylindrical shape whose cross-sectional area is A, and it is kept at a height difference of H1 and H2 minus H1. So H1 and H2 means what? Be the depth from this air water interface of this level 1 and level 2, and the force which is acting, F1 is a force which is acting downward, and F2 is the force which is acting upward. Now you know the formula, pressure P is equal to F by A. From this we can find F is equal to P into A. So F1 means P1 A. F2 means what? P2A. So this you keep it in mind. Now you can take the free body diagram. This is what the sample. So there is a force, upward force, F2 is acting upward and F1 is acting downward. Along with this force 1 and gravitational force mg also acting. Now you can take the equation from Newton's second law. The total force here acting is F1 plus mg equal to what? F2. Now you have to find out this mass. To find out the mass, we can use the density formula. Density is equal to mass per volume. So from that, the mass is equal to what? Density into volume. Now you have to find out the volume. So that you can use volume is equal to area into height. Here h means what? H2 minus h1. Pressure height difference you have to take. Now you have to substitute this volume value here. So what will come? M is equal to rho into A H2 minus H1. Now you can substitute this equation 2 in this equation 1. Instead of this M value, you have to substitute this M value. So we will get equation like this. F1 is equal to rho into A H2 minus H1 G equal to F2. Now you have to substitute this F1 and F2 value. F1 is what? P1A and F2 is P2A. And while substitute, we get here A, and this side also A. Take this A outside and cancel both side A. So you will get equation like this: P1 plus rho into H2 minus H1 into G equal to P2. From that you can find out P2. P2 is equal to P1 plus rho into H2 minus H1 into G. So this is what happened when we, this will be the pressure while we keep an object inside of the water. Now we can keep some case, something like the P2. We are changing the level. So here the height H2 we have taken as H, and height H1 is 0, and this pressure acting P1 is what? Atmospheric pressure PA, and P2 is P. Now we are substituting all these in this equation. P2 equal to P, P1 equal to PA. Atmospheric pressure H2 equal to H and H1 equal to 0. We substitute all these in this equation. P2 instead of P2 P. So P is equal to PA plus rho into H2 minus H1 into G we will get. Now we know that height H1 is 0. So H2 is H. So we will get P is equal to rho A, PA plus rho Hg. Now the atmospheric pressure you can neglect. So while we neglect this atmospheric pressure, what you will get? Rho P is equal to rho G H. And you can mark this question. It is a long answer, question number 4. From this part you can mark. Consider a water sample of cross-sectional area. You can mark like this, and this 2 diagram, free body diagram. The next page, until this you have to. So this is long answer, question number 4. Until equation 7.18 you have to write. So my dear students, practice this derivation. It is one of the important question from this unit. And see you all. Bye bye. Thank you.